technique in solving the problems in the network analysis. Using this source transformation, we can simplify any circuit in the network analysis. So as its name suggests, it is related to the source, and the source is here nothing but voltage and the current. So using this source transformation, we can convert any voltage source into the current source, or vice versa, any current source into the voltage source. So let's say we have one voltage source Vs with a series resistance R that is connected to a sum network via terminal AB. So using this source transformation, we can convert this voltage source into the current source Is with a same resistance R in a parallel with this current source. Likewise, if we have a current source Is with a resistance R in a parallel in any network, then that can be converted into the voltage source Vs with the same resistance R in a series with this voltage source. So here during the transformation, the characteristic of the network do not get changed. That means the voltage across this terminal AB and the current that is entering into this node A will remain the same after the transformation. So let's say that voltage across this two terminal AB is Vx and the current that is entering into this node A is Ix. So we can write Vx is equal to Vs minus Ix into R, that is a drop across this resistance R. Similarly, for the transform network, the voltage across these two terminal will remain the same, that is Vx, and the current that is entering into this node A will remain the same, Ix, after the transformation. So here we can write Vx is nothing but drop across this resistor R. Let's say that is a I into R, where current I is the current that is flowing through this resistor R. So here I is nothing but Is minus Ix. So we can write Vx as Is minus Ix into R, that is nothing but Vx is equal to Is into R minus Ix into R. Now here we can compare these two equations. So we will get Vs minus Ix into R is equal to IsR minus Ix into R. So these two terms will cancel out. So we will get Vs is equal to Is into R, or we can write Is is equal to Vs divided by R. So here in this way we get a relationship between the voltage and the currents. So if we have a voltage source Vs with a series resistors R in any network, that can be transformed into the current source Is with the same resistance R in parallel with this current source. And the value of this current source will be nothing but Vs upon R. So let's take one example. Let's say we have a 30 volt voltage source with resistance of 10 ohm in series that is connected to a some network. So we can transform this voltage source into the current source with the same 10 ohm resistor in a parallel with this current source. So the value of this current source I will be given as V upon R, that is nothing but a 3 ampere. So in this way we can transform this 30 volt voltage source into a 3 ampere current source with a 10 ohm resistor in a parallel. Likewise, let's say we have a current source Is with a resistance R in a parallel in any network that can be transformed into the voltage source Vs with the same resistor R in a parallel. And the value of this voltage source Vs is nothing but Is into R. So let's take one example. Let's say we have a 1 ampere current source with 10 ohm resistor in a parallel. So we can transform this current source into the voltage source with the same 10 ohm resistor in a series with this voltage source. And the value of this voltage source V is given by I into R, that is nothing but 10 volt. So in this way we can transform this 1 ampere current source into the 10 volt voltage source. So now let's take one numerical and find the usefulness of this source transformation in simplifying the circuit. So here we have one circuit. In this we need to find a voltage across this 2 ampere current source. Let's say the voltage across this 2 ampere current source is Vx. So we need to find the voltage across this 2 ampere current source. So just by looking at the circuit, it looks bit complicated to find the voltage across this 2 ampere current source. But we will see that using the source transformation, we can easily find out the voltage across this 2 ampere current source. So first of all, let's just concentrate on this left portion of the circuit. Here we have a 4 volt voltage source which is connected with a 6 ohm resistor in a series. So we can transform this voltage source into the current source so that we have this 6 ohm resistor and 12 ohm resistor are in a parallel. So first of all, let's just transform this 4 volt voltage source into the current source. So in the equivalent circuit we will have a current source with a same 6 ohm resistor in a parallel. And the value of this current source I is nothing but V upon R, that is 4 volt divided by 6 ohm, that is 2 by 3 ampere. So in this way we can transform this 4 volt voltage source into this 2 by 3 ampere current source. So we will have a 2 by 3 ampere current source with a 6 ohm resistor in a parallel in the equivalent circuit. So now here, as you can see, now we have this 6 ohm resistor and 12 ohm resistors are in a parallel. So here the equivalent resistance is, let's say, Rp, and it is given by 6 ohm parallel 12 ohm, that is nothing but 6 into 12 divided by 6 plus 12, which is nothing but a 4 ohm. So here we can replace these two resistance by their equivalent parallel resistance. So the equivalent circuit now will have a 2 by 3 ampere current source with a 4 ohm resistor in a parallel. So now here again, as you can see, we can transform this current source into the voltage source so that we have this 8 volt voltage source with this transform voltage source in a series. So now let's convert this current source into the voltage source. So here now we have a 2 by 3 ampere current source with 4 ohm resistor in a parallel. So their equivalent transformed source will have a voltage source with 4 ohm resistor in a series, and the value of this voltage source V is given by I into R, that is 2 by 3 into 4 ohm, that is nothing but 8 by 3 volt. So we can replace this 2 by 3 ampere current source into this 8 by 3 volt voltage source. So the equivalent circuit now will have a 8 by 3 volt voltage source with 4 ohm resistor in a series that is connected to this 8 volt voltage source. So now here we have this 8 by 3 volt voltage source in series with this 8 volt voltage source. So we can replace it with a single equivalent voltage source. So we will have now 8 plus 8 by 3, that is 32 by 3 volt. So we can replace these two voltage sources by this 32 by 3 volt voltage source. So the equivalent circuit now will look like this. Now we have this 32 by 3 volt voltage source in series with this 4 ohm resistor. So here again now we can convert this voltage source into the current source, so that this 4 ohm and 12 ohm resistor will come in parallel. We can simplify this circuit. So here this 32 by 3 volt voltage source can be converted into the current source with this 4 ohm resistor in a parallel. And the value of the current source I is nothing but V upon R, that is 32 by 3 divided by 4 ohm, which comes out to be a 8 by 3 ampere. So we can replace this voltage source with their equivalent current source, and the equivalent circuit now will look like this. It has a 8 by 3 ampere current source with 4 ohm resistor in a parallel. So as you can see, now we have the 4 ohm and 12 ohm resistor are in a parallel. So we can replace these two resistors by their equivalent parallel resistance. Let's say it is Rp, and it is given by 4 ohm parallel 12 ohm, and that is nothing but 4 into 12 divided by 4 plus 12, which comes out to be a 3 ohm. So we can replace these two resistors by their equivalent parallel resistance 3 ohm. So now the circuit will have a 3 ohm resistor in parallel with these two current sources, and the voltage across this 2 ampere current source is nothing but the voltage drop across this 3 ohm resistor. So Vx can be given as 3 into I, where I is nothing but a current that is passing through this 3 ohm resistor. So value of I is given as 2 ampere minus 8 by 3 ampere, which comes out to be a minus 2 by 3 ampere. So we can write this I as minus 2 by 3 ampere. So we will get a Vx is equal to minus 2 volt. So in this way, using the source transformation, we can easily simplify any circuit and find the parameters in the any circuit. So I hope you understood what is source transformation and how it is useful in simplifying the any network or circuit. So the link is provided in the description below to download more such examples based on the source transformation, and if you want the solution for the same, please let me know in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.